Hello, welcome back. Today we are going to do lesson 2 in our geometry unit. So this is only the second lesson in our unit, but we're going to start to get a little bit difficult pretty quickly. So today we're going to be studying the perimeter. We're going to really focus on perimeter. There's a little bit with area, but mostly perimeter of triangles and trapezoids. So the learning objective today is learn to find the perimeter and area of triangles and trapezoids. I have some notes here in the center for you. First with triangles, in words to find area, obviously perimeter is going to be just like it was when we were doing our lesson before. You just add up the lengths of all the sides and pull those together. But in order to find the area, you are going to take 1/2 of the base length, which will be represented by the letter B, times it by the height, which is h. So you can see the formula over here. Area equals 1/2 of the base times height. And then if you want to see an example including numbers, you can see that in the middle here where you've got a base of 8 and a height of 4. So they've just substituted an 8 in for the B and a 4 in for the H to get, once you multiply all that out, 1/2 of 8 times 4, which is 16, and then units squared because we are doing area. And then for the trapezoid is going to, in words, the area of a trapezoid, again, is 1/2, and I'll show you in a minute why it's 1/2, but 1/2 the height times the sum of each base. A base is going to be at a right angle. This is super important right here. The right angle, and I'll show you an example way later in the lesson, but it's going to be making an average of those two bases, the top and the bottom. So its area equals 1/2 of the base 1 plus base 2, and then multiply that times height, which is the formula right here. And like I said, if you want to see an example, not very in depth, but with some numbers, we've got 1/2 and then the height, which is 2, and then you've got your base 1 and base 2, so here's base 1 and here's base 2, 3 and 7, which is where they got 3 and 7 from, and then when you multiply it all out, they got 10 units squared. So at the bottom here it says a triangle or trapezoid can be thought of as half of a parallelogram. So you can see here a triangle, like it's right here is a parallelogram, and then when they split it right down here, it turns it into 2 triangles. So to get the area of just one of those triangles, you would just take half of that area. And then it's the same for a trapezoid. So when you take a parallelogram and split it in half, you end up having this shape right here. And just to find the area of that, it would just be half of what we had before. So that's why it's 1/2 of the basically what we would do for a parallelogram. So let's get into doing some examples. We're going to start off by doing perimeter. So perimeter of triangles or perimeter of trapezoids is going to be the same, because for perimeter you're going to be finding that rim, the distance around the outside of that object. So for part A, or letter A, we've got this side, which is 4, and we're going to add to that this side, which is 10, and add to that the final side, which is 7. So when you add all of those up, 4 plus 10 is 14, and then 14 plus 7 equals 21, and this is really messy. So for example 1A, we should get 21 units. Okay, now for the trapezoid, we're going to do the same thing. We are going to be adding up just the distance around the outside. So for this edge, our distance or our measurement is 11, so we're going to take 11, and we're going to add to that this side of 8. Obviously up next we have the bottom, the base, which is a length of 17, and then finally the final side, which is 6. So we're going to take those numbers and we're going to add them up to get the total to get our perimeter. So you can do a little simplification. 11 plus 8 is 19, so we've got 19 plus 17 plus 6, and then you can use a calculator or you could continue like this. and you would get a total of 32. So adding up all 4 of those sides, you get a total of 42 units. Like, this is going to be just units, not units squared, because we're just going in a one-dimensional distance. It's not going to be that two-dimensional where we've got the square. So 32 units for part B. Okay, the next part I'm going to have you do is a you-do. So they're just exactly like the last 2 we did, however, they've got different numbers. So on your paper, you will see right below these examples, example 1A and 1B. I would like for you to figure out the answers to these and then write your answers. At the end of this lesson, I want you to either have me check it or turn it in and I'll check it and get it back to you. But I want to check and see if you can figure these 2 out on your own. Okay, up next we have finding a missing measurement. So in this example, they're going to give us the measurement of the perimeter, what we should be getting, and then we're going to have one of the side measurements is going to be missing. So like in this one, they're using the letter D. So D is representing the missing dimension. But they're telling us that the perimeter of the whole trapezoid is 71 inches. So when we add up all 4 sides, this side, this side, this side, and this side, it's going to equal a total of 71. Okay, so I've written this out. I have 18 plus 15 plus 22, and then plus the missing dimension of D, and all of that is set equal to 71, which they told us in the original problem. Find the missing measurement for this trapezoid with a perimeter of 71. So what we're going to have to do is solve for that D. So you want to, if you need to, you can shape code. This is a number term, 18, 15, 22, and then we've got D, which is not, so that would be like if you wanted to box it or do something different. And then over on this side of the equal sign, we've got another number. So what you want to do is simplify this and add these all up. So 18 plus 15 plus 22, that's going to equal a total of 55. You could use your calculator or you could add it on paper, whatever, however you're most comfortable doing that. And that equals 71. So now to solve for D, you have D plus 55. So to solve for D, you want to get rid of plus 55. So you're going to subtract 55 from both sides, which cancels that out. So you're left with D equals 71 minus 55, which is a total of 16. Over here you can see that we've measured in inches, so our unit is going to be another inches. So this right here, D, is 16 inches. So now on your paper you'll see again another example. This is a you do, so I'm going to have you attempt to figure this one out. Find the missing measurement for this trapezoid here on the bottom with a perimeter, a total perimeter of 58 inches. So you're going to be setting your 14 plus 7 plus 28 plus D, you're going to be setting that equal to 58. So see if you can solve for that missing length, and then I will either check it for you when I get around, or you can turn it in, but make sure that you're getting it checked to see if you're doing things correctly. Okay, next example, we're going to get into multi-step application, and when it says multi-step, let me tell you that this is some multi-step stuff going on. So let me read through the problem. It says a homeowner, so somebody who owns their house, wants to plant a border of shrubs, aka like tiny little bushes, around her yard that is in the shape of a right triangle. So her yard is shaped like a right triangle. She knows that the length of the shortest side of her yard, shortest side, is 12 feet. And she also knows that the length of the longest side is 20 feet. So how long will the border be? So when we think about how long, we're thinking about the perimeter. So let's go back to, I'm a picture drawer. Let's go back to the fact that her yard is in the shape of a right triangle. So what a weird yard. But here's her right triangle yard. So here's grass. Yeah, this is her yard. Weird. But she wants to plant shrubbery all the way around the outside. And I'm being a dork now and I'll stop. But it's Yeah, it's in the shape of a right triangle. So she knows that the length of the shortest side, so we know that this is our B and A and B, and then our longest side is over here, C. A and B are going to make up our two short sides connected to our right angle. So for our shortest side, it's 12. And then they also tell us for this example that our longest side, our C, in this example is equal to 20 feet. So the one that we're missing for this is our B. Now, what you're going to do is you're going to use the Pythagorean theorem in order to solve for B, to figure out how long B is, and then from there, once we have B, we can figure out what the perimeter is by adding up all the sides, because right now we know that it's 20 plus 12 plus B, but we don't have what it's equal to. We're trying to solve for that. But because we know the Pythagorean theorem, and that Pythagorean theorem is a squared plus b squared equals c squared, we can solve for that distance of B. So we're going to come in and do some substitution. We knew that our shortest side was 12, so our A is 12. So I'm going to substitute that. They don't tell us what B is. That's the one we're going to be solving for, and that's equal to our longest side, which was 20. So we're going to do some multiplication. You can use your calculator for these if you want. 12 times 12, 12 squared is 12 times 12. That's going to be equal to 144. Bring down B squared, and that's equal to 20 times 20. Put that in your calculator if you need to. 20 times 20 is 400. So now we need to solve for B. So we've got, if you need to do shape coding, you can do that. A number, our B term, and then we've got another number over here. So we need to move this guy, 144, over here. So the way we're going to do that, this is positive. We're going to do a negative or a subtract 144. If I do that over there, I have to do it to both sides, so that cancels out. We are going to be left with B squared equals 400 minus 144. You'll get 256. So now you have B squared. We want B squared, though we want just B. So if something's being squared, to get rid of a square, you want to do the square root. So if you take the square root of one side, you have to take the square root of both sides. So that square root bar is going to cancel out. We've got B all by himself equals square root of 256, again, calculator if you need to, and you'll get that B is equal to 16, and we were dealing with feet. So this is only halfway done, because now we know that B is not B. B is actually 16. But because we now have this piece of information, we can go ahead and solve the last question. Okay, so I cleaned up a little bit. I erased some of that junk that was over here. And now I have added on there that the border is going to be equal to this distance, 16, plus the bottom, which is 12, plus 20. So we've got all sides of her backyard represented. So 16 plus 12 plus 20. So when we add those all up, we get a total of, let's see, 28 and then plus 20. So 48 feet is going to be our final answer, because that's the distance that it is around this homeowner's backyard. Now, if you will go ahead and flip your paper over, you're going to see a problem at the very top of your page that is going to be a you do question. So this is exactly just like the question we did. We have a gardener who is planting a border of flowers around a building. That is extremely weird. A building that's in the shape of a right triangle. So this time our building, or our right triangle, is being portrayed as a building. So top of our building, and then the bottom of our building, we want to plant pretty little flowers all the way around the outside. He knows that the length of the shortest sides are 38 and 32. So shortest, shortest, shortest. A, B, and C. This is a hint that the shortest is going to be your A and B. So you're going to substitute 38 and 32. And for your A and B, I just want to get you started so that you don't get tripped up there. This one's 32, this one's 38. And so now you'll use the steps like before where you use your Pythagorean theorem, a squared plus b squared equals your c squared. And you're going to substitute and then do your square roots to find c this time. So you'll be adding them together. But and then take that total to find your perimeter. But just so you know, it's not going to come out perfectly. You will have a decimal that you'll have to round. I'd like you just to round it to the nearest whole number so that we don't have any decimals for your answer. But if you get stuck, just holler, let me come help you. And then when you get that one finished, if you want me to check it or turn it in or whatever, but this one is for you to finish on your own. Okay, we're finally in the home stretch. Example 4. So we're going to find the area of triangles and trapezoids. Now we're finally doing area. And we're going to do this by graphing coordinates onto a plane and then finding the lengths by counting the numbers and getting all of our measurements that way. Again, this is multi-step, so take your time. So we're going to graph the vertices to start with. So the first one is -2, 2. So I'm going to walk to -2 and then go up to +2 and put my point. So there's my first point. You can tell we've got 3 points, so it's going to make a triangle. Our next point is at 4, 2. So you go over 4, walk to 4, and then ride the elevator up to 2. So there is our first side of our triangle. And then to find our last point to make our triangle connect, we're going to go nowhere, stay at the lobby, but we're going to ride up to 5. 1, 2, 3, 4, 5. Put a dot. And now I'm just going to draw my size in, not perfect, oh well. So we need to review though, remember that our formula for a triangle, area equals 1/2 of our base times our height. So in this example, to find our base, we need to count how far this is right here. So we've got 1, 2, 3, 4, 5, 6. So that is a base of 6. I'm just going to, what the world? Yeah, I'm just going to substitute 6 for my base over here. And then to find my height, I need to do the same thing. Right here is height, so I need to count 1, 2, 3 for my height, so I can substitute in 3 here. And then our area, just finish out the formula, is 1/2 of our 6 times 3. So 6 times 3 is 18. 1/2 of 18 is 9. And then we don't have like centimeters, feet, whatever, so we just call it units, and because it's in area, it's squared. It's like if it was centimeters, it'd be centimeters squared. I swear I can talk. Centimeters squared, or meters squared, or feet squared, inches squared, whatever it happens to be in. Okay, the next one, and this will be our last one that we do together before you do your CFU. We're going to graph these vertices again and do just like before, but this time it's going to end up creating a trapezoid. I'll kind of make that not a surprise for you. But so our first coordinate's at -1, -2, so go to -1 and then write down 2. Second one is at 5, -2, so go over 5 and go down 2. Next one is pretty similar, 5, +2, so go over 5 and then up 2. What the world? And then -1, 6, so we're going to -1 but up to 6. 1, 2, 3, 4, 5, 6. Put a dot. So these are our coordinates. Now I can connect this. This is going to be super tricky because in order to have a trapezoid, our bases have to be at right angles. So if we were to connect anywhere here, this is not a right angle because we have a slant right here. So I'm not going to use that right there. What I'm going to use is actually this sideways thing. So like we create a right angle here, we create a right angle here. So we're going to use this one and this one as our base 1 and base 2. I should probably review that the area for a trapezoid is equal to 1/2 of the height times base 1 plus base 2. So in order to find our base 1, we can use this one. It doesn't matter which one you use, but figure out the distance from here to here. So we've got 1, 2, 3, 4, 5, 6, 7, 8. We have a distance of 8 for base 1 or base 2. It doesn't really matter. And then for our other base is this one. So from here to here, we've got 1, 2, 3, 4. So this is going to be plus 4 down here. And then to find our height, it's going to be that measurement right here in the middle, how high it is or how far it is from base to base. So from base to base, we are going 1, 2, 3, 4, 5, 6. So this is a 6 right here. So if we finish out our formula, we've got area equals 1/2 times our height of 6 times our bases, base 1 and 2 of 8 and 4. So 8 plus 4 is 12. And then if you want to simplify, like 1/2 of 6 is 3. So 3 times 12 equals 36. And again, it's in units squared. There's nothing listed as to what kind of units, so we'll just call it general units squared. Okay, so to finish off these notes and be done with this lesson, you're going to do your CFU, your check for understanding, which is down there at the bottom of the page. Looks like this, exit ticket, whatever you want to call it. You can have me check your answers again if you finish before class is up, or you can turn it in. I'll get it back to you tomorrow. Just make sure that at some point you get it turned in, because I'm going to be giving 5 points. It's not a lot, but I'll be giving 5 points for each assignment so that you can at least get a little bit of credit as you are working so hard on all this stuff to learn it. And then tomorrow, obviously, you'll do the practice on that quiz or on paper, however you prefer, to kind of review and make sure you understand this stuff on your own. So go ahead and finish up that CFU and get it checked or turned in, and I will see you guys later.